6, A, B, and C on the wheel. We still have more homework to assign, but I wanna start getting some problems on it. So we do this,
Please excuse the interruption. Brody Knapp, report to Mrs. Seller's room.
Always getting into trouble.
alright, I'm doing that. Who's doing B?
Wait, you mean like copies?
6.
Like these ones?
Problem number 6. Use electron dots structures to demonstrate the formation of ionic bonds.
Okay.
Thank you, Ms. Seaborn.
Thank you. You don't see two.
No, because we don't have it ready yet.
Okay.
Okay. All right. I like it, but you have to show the first half. Go ahead and have a seat, I'll get it ready. Listen, just a little bit of busy work on this problem, okay? I like what you did here. Please tell us. I'll show this one more time, I apologize for this. How many dots in the dot symbol for this group?
8, 7, 6, 5, 4, 3, 2, 1.
Okay? We're using dot symbols, okay? What ions are formed? Okay? So we're forming ions, but we're doing both here. So we have to show, here's where we're headed. Let me fast, so listen, of anything on this next test, if you fail, I really don't care. If you don't know how to draw these, it's okay. Because here's what we're gonna do. The very next chapter, like Bryn did right here, we're just gonna take magnesium, which we look, man, there it is in group 2. We know it wants to be a +2. We're gonna bond it with bromine, which we know wants to be a -1. We're gonna cross those. That 1 comes down here, which we don't show it, but I'll show you, and 2 down here. We have 2 -1s and 1 +2. And then we erase the charges up top. We don't show a 1. And there's magnesium bromide. That's where we're headed. Okay? This chapter says we want to show that formation. We want to show what really happens. So here's what really happens. She almost has it. We need to show, you kind of need to do this and know that they're going to take 2 bromines, which she has. She just didn't show the first half. Let me show the first half of this. We have magnesium. How many electrons in its outer shell? 2. We have 2 bromines. How many electrons in their outer shell?
7.
There's a bromine with 7 in its outer shell. There's the second bromine with 7 in the outer shell. And then we draw an arrow on the right side of the arrow. There's magnesium with a +2 charges giving away both its electrons. And there's each bromine with a -1 charge. And she actually circled the ones that were added to it. And watch this. You don't have to, Schultz did it on hers, watch this, you can actually show that this electron got added over there, and this electron got added right there, if you want to. She put an equal sign, she needs an arrow. She showed it, need a plus sign there. I'm glad no one did this, watch this, a lot of people do this. A lot of people, they'll put potassium bonded to fluorine. What is that? What type of bond? It's a covalent bond. That's two atoms that are sharing electrons. Do they share electrons? These do not share electrons. Everyone understand that? So, if they shared electrons, we would draw it like that and draw its Lewis structure. These aren't sharing electrons, these are ionically bonded, so they're exchanging electrons. Or fluorine is stealing electrons. Queen fluorine, she's not going to share with anyone. She's stealing electrons. So there it goes. There goes the electron. Over here, we have, make sure you put the plus in between. They're bonded by a static charge. We have potassium with a +1 charge. We have fluorine with now how many electrons in its outer shell? 8. Show the 8 electrons in fluorine's outer shell, and this one was right. Okay?
Wait, so you keep the plus and the minus?
You keep the plus in mind. Yep, you keep the plus. Keep the pluses in between.
So for mine, I was in the.
You need to put the first half. Yeah, yeah. I like what you did. You figured out what you needed, and then you showed the second half. Just show the first half. Again, this is, I like it in the fact that it shows you visually what happens. One thing I don't like about it, but this would mess people up. We show this magnesium, now here it is, it's unhappy. It has no electrons. It is sitting there pouting, it has no electrons. It's a +2 charge with no electrons in its outer shell. What's it really have? 8 in its outer shell, it's perfectly happy. Let me show it again, watch this. Magnesium is 1s2, 2s2, 2p6, and 3s2. There it is, 12. If it got rid of those 2 electrons, doesn't it now have an octet? Isn't it now very stable, like neon? It's become like neon. It's perfect. So it's not sitting here all lonesome. It's perfectly content, perfectly happy with 8 electrons in its outer shell and a +2 charge. Why is it bonded to these? Static charge. It's essentially negatives being attracted to a positive, and it's just bonded together. And in some respects, it's a very strong bond. Throw it in water, it's a very weak bond. We'll talk about that later on what they're soluble in. That's an ionic. What's the last one? Was the last one a fun one? Aluminum and iodine. We should probably do aluminum and iodine. Who wants to come to the board and do aluminum and iodine? No one? All right. You have a seat? You don't want to see it? You want to erase that? You can write there, you can write. All right. Well, I'll have a seat. Perfect. Don't rewrite it, don't rewrite it. Just put all your dots. on iodines. Got it. Yep. Can you see that?
That's,
Can you see that? There's the left side. Aluminum still has 3 electrons in its outer shell. The arrows kind of muddy things up a little bit if they're getting away. You don't need to put them. But it takes 3 iodines to cancel out the charges on aluminum. Each one takes 1 electron. And then we have aluminum with +1 charge and 3 iodines, each one with a -1 charge. That's it.
so on like a test, you want us to put it in like where it has the aluminum and then the 3 like separate items with the dots around. Okay. What if we put like, instead of 3 separate I's, we put like I, 3, and then dots? Like,
Like up there, that MG marks it.
yeah, and we just put the dots
No,
around? Okay.
no, you need to show each one. You need to show each one. It's a little bit tedious. Down the road, we won't. Watch this. Oh, sorry. Carbon fluorine. What's the formula? Well, isn't that a -1? Isn't this a +4? If that's a +4, will the 1 come down here and not be shown? Will the 4 come down there? There it is. There's carbon tetrafluoride. Every time.
So that's not.
We just have aluminum right there. Aluminum iodide. +3, -1, we cross the charges. This is where we're heading. It's gonna be much easier. Why do we do this? Because I want you to understand the difference between ionic bonds and covalent bonds. So when it's covalent, we have those electrons being shared. Are we good with this? That's the only question we have with ionic bonds. All the rest are gonna be Lewis structures that we're gonna put up here today, and we're gonna follow these steps. Identify the type and number of atoms, draw the dot symbols for each type of atom, determine the total number of valence electrons, then make a skeleton structure, add unshared pairs of electrons, and check and see if the number's correct. If they're not, we do double bonds or triple bonds, and that's it. So we should be getting pretty good at this. So, right now, let's have some people to the board. I just did carbon tetrafluoride, we raw, this is good. Let's draw Lewis structures for number 5, A, B, and C. All right, you're doing A, you're doing B, you're doing B, you're doing C. All right, come grab a marker. We're doing 5, A, B, and C. Is anyone do my chair?
No.
Are you sure?
Thank you.
Make sure you're still working on the names. So part of this test will also be writing the names of the elements. That doesn't go away, very next chapter. I just showed you, we combine them ionically and name them. Now, I'll show you something. Every once in a while, I'll have someone panic on test. They don't come up. If this happens, you come up and show me. And like, I don't have enough electrons, there's no way I can do this. Because they put nitrogen at a -3, and they do this one at a -1. Do you understand what I'm saying? They do the ions, 0, -1, -2, -3. And so they have 1 times 3 is 3, and 3 times 1 is 4. They only have 7 electrons, and they don't know what to do. Do you understand? I've had people start slapping double, triple, quadruple, trying to get 8 in their outer shell. It can't be done. So if you happen to draw that blank, remember, you're now, and that's why we have you draw the dot symbols. Okay? So, there's 1 nitrogen, there's 3 iodines, times 5 and 7 gives us 26 total electrons. Watch this. Make sure these lines you count as 2. 2, 4, 6, 8 around the nitrogen, 2, 4, 6, 8 around each iodine. A total of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We're perfect. Got it? Here we go. Right there with carbon. 1 times 4 is 4. Fluorine, 4 times 7 is 28, total of 32. There it is. Every single one has 8 in their outer shell. It's perfectly happy. Let's look at this. What does this remind you of? H2O. Everyone see that? Instead of having oxygen in its center, we're down 2 elements. See how it has selenium? Still the same, 6 in its outer shell. So there we are. Selenium is 1 times 6, we're a total of 8. 2, 4, 6, 8. Remember, I've had people do this and it gets crazy. I've had people put dots all around their hydrogen. Remember for this rule right over here, add unshared pairs of electrons to satisfy the octet rule, not hydrogen. Okay, I will put that on there. Hydrogen wants 2 in its outer shell. It will become like helium, and it has the duet rule instead of the octet rule. Folks, this is it. We can put these in on here all day. Can we jump to let's do E. Let's put E on there, 5E, and then let's jump to some of the polyatomics that are a little bit more difficult. So whoever wants to come up and do 5E, let's do 7D. So 5E. Let's do 5E, let's do 7D, and then we're on to the next page. Let's do 7E as well. Five E, 7D, 7E. Can I erase these to give us more room? We got those, you guys all have those down? Okay, guys. Remember, when you get this next test, I would write on it, that scale right up top there. Your homework has been talking about Vesper. It says you use the Vesper to talk about shape. I'm not gonna worry about that. We're not gonna talk about that. I'll let them cover that in college instead of having you worry. I'll show you one here that is a little bit different. Okay. All right, let's take a look at these. We have a total of 14. Why did you make the carbon the central atom? Whose is it? Carbon has 4 places to bond. You ever see that? You ever see that? Hydrogen only has 1 place to bond. Chlorine only has 1 place to bond. That makes carbon the central atom. 2, 4, 6, 8, 10, 12, 14. That's perfect. That's perfect. Let's look at this one. Chlorine, carbon. Carbon 1 times 4 is 4. Oxygen 2 times 6 is 12. We're at 16. 2, 4, 6, 8 around that oxygen. If you get confused, another thing, you can play around with this until you get it. As long as each one has 8 in the outer shell, 2, 4, 6, 8 around the carbon, 2, 4, 6, 8 around the oxygen, total 2, 4, 6, 8, 10, 12, 14, 16, that's good. That's linear, so when we talk about Vesper, this ends up being linear. You have different shapes. I put this one on here because I want to show you something, believe it or not, this is actually wrong. Now, the way we do it, I want you to do it this way. And I'm not gonna mark it wrong. I'm not gonna give you this one, but I wouldn't mark it wrong. This is how you're supposed to draw these. Watch this. We have boron can bond in 3 places. We have 3 chlorines. It makes sense. So there it is. That makes sense. We had unshared pairs of electrons. We have a total of 24, and we start adding them. And we have 26 electrons. We only have 24. We've made a mistake. And so we erase 2 from here and 2 from here, and we do the double bond. That's exactly what you should do. Okay? Believe it or not, it's not what happens. And down the road, this is a long way off. We get to chapter 16. We start talking acid-base chemistry. This is going to end up being an acid because it's not like this. Here's what happened. Watch this. You draw this differently. Watch this. Boron has 3 electrons in its outer shell. This chlorine was 7. This chlorine was 7. This chlorine was 7. These 2 get shared. These 2 get shared. These 2 get shared. That's it. Can't double bond. There's not really here any to share. As a result, boron's unhappy. Boron is minus some electrons. It acts aggressively. So that would become an acid. It would act aggressively and try to gain electrons and rip things apart. We'll worry about that when we get to acid-base chemistry. As of right now, That's correct, that's what I want you to do. The method they have to do those, and I'm not gonna assign that one, but I assign that in homework, I'm just kinda curious. And as a result, it changes shape, they want us to recognize that shape, well, that's more than I want you to know at this point in time. So that's why I get rid of the Vesper theory, because we're not catching that yet. Notice that was down there on the one where draw Lewis structure, then predict the molecular geometry of each. Listen, it's almost Christmas time. Right now, I want you to believe that that life works out perfectly and everything always gets its way. Don't you want to get what you want for Christmas? So let's stay in that make-believe world for now. And we'll address this later, and that's kind of why I leave the Vesper theory out of this. Okay? We'll talk about a few, we'll talk about like linear, but that's okay. I want now, what do we have? We have a bunch of ones to do on Lewis structures. So let's go to application problem number 4, and let's go A, B, C, and D. 4 A, B, C, and D to the board. Man, folks, we'll have this done. We're gonna be taking this test pretty quickly. There's really not a lot more to do. We might have to do, I think that's what we're gonna do. We've got a lab coming up before Thanksgiving, that will be fun. So let's do application problems A, B, C, and D on the board. Have at it. It's okay if you don't have your homework done, just go to the board. Seriously, I need someone to the board making mistakes. Carol, get to the board. You don't have to go to the board and make mistakes. We're doing A, B, and C right now. That way have room. Do you understand? I appreciate mistakes being made at the board. I am going to get a red marker and I'll just slash and burn. But you need to see some mistakes. Don't you have practice like for your sports and make mistakes in practice? Learn from them and then not make them in a game. What's the charge on that?
It's -2.
-2, so what do you do to that 22?
I think it's fine.
No, show what you do. No, leave that 22, because I'm gonna check.
So then,
Huh? If it's a -2, has it gained 2 electrons or lost 2 electrons?
gain.
Gained 2.
So
Add
that's
2.
24.
No, don't just put 24, put a +2. Now you've got the right number of electrons. Yep, did you see that? Whenever it's called a polyatomic ion, we've already defined it. Whenever you're given one of those, you have to make sure you add the extra electrons to it. I will not mark that wrong. Okay, I'm just gonna let you know. I don't know what it's saying. Beautiful. All right, now keep.
Wait, I'm kind of confused on how to do the, like, charge thing.
Okay. Hydroxide, what was its charge?
-1.
-1. Yeah, you did it right, you added an electron, so there's 8.
Okay.
I have that marker. All right, let's grade these. So watch this. Now, listen, I appreciate you doing that to help count this. Please, make sure you just put OH, okay? Polyatomic ion, we'll learn the name later, it's hydroxide, we have OH, we actually have an IO. And so we'll learn IO. And that's a polyatomic ion, 1 oxygen, 1 hydrogen. So here we go, oxygen, 1 times 6 is 6, hydrogen, 1 times 1 is 1. We add them together, we get 7, but we've gained 1, we have 8. There it is. You simply make a skeleton structure. Why did you add extra electrons to the oxygen and not the hydrogen?
Because it's, has the, like, S thing, we can only have two.
Bingo, right there it is. Right there it is. It has a full outer shell, it's happy. They're both happy. Watch this. We have to put parentheses around it and show it that that thing's gaining an electron. There it is. That's the only thing you were missing. This one's technically wrong, but I won't mark it wrong. Can anyone see what's wrong about it?
They can't bond in 4 places.
Sulfur can't bond in 4 places. So believe it or not, because both of these, your math's is goofy for me. I'm not quite sure what's, oh, you get it now.
Yeah, I'm confused too, like, I think like,
Make sure, watch this, I wanna see this, cause I wanna check the math. So, sulfur, I expect to see you be able to look at that and see this invisible 1 here. You would say there's 1 sulfur
I just.
times 6 is 6.
Oh, I see how you did it.
Did you do silicon at 4?
No,
No,
like
I
go
did,
down,
go
like
down.
S1 times S6 is 6.
Gotcha. Okay. Alright. You know what? I'll let you do it. I'll figure it out. So then there's 4 times 6, 24. Gotcha. Alright. That'll work. You see the dot symbol? Sulfur has 2 places to bond. So as a result, it's gonna look like this. I don't care that much. You understand? That works, we're gonna allow it.
On the test too?
Hmm?
On the test too?
We're trying for symmetrical. I said, let's try and make them symmetrical. And that'll work. Let's look at this. We have carbonate, CO3. Carbon, 1 times 4 is 4, 3 times 6 is 18, we're a total of 22. It's a -2 charge. When we add them on, she mistakenly had 26 instead of 24 dots. So she erased 2 from here and 2 from here and made a double bond. I would have gone 2 from here and 2 from here, but that's just me. Doesn't matter. It doesn't matter which one she made a double bond with. Here it is. As long as 2, 4, 6, 8 around this oxygen, 2, 4, 6, 8 around this oxygen, 2, 4, 6, 8 around that carbon, 2, 4, 6, 8 around that oxygen, we're good. We're good. Let's do D, E, and F. D, E, and F. We get D, E, and F. Now, is there anything else for us to cover? How are we going so fast? You guys are that smart. We're gonna get into deep water in your class. I'm excited about that. We may throw in, I've got a fun lab. I've got a fun lab we'll throw in, slow us down around Thanksgiving. That'll work. Let's put D, E, and F on the board. And then maybe we review tomorrow and go chapter 5, 6 test on Wednesday, Thursday. Doesn't seem possible. We have a little bit more discussion to do on solids, liquids, and gases, I think. So maybe we'll do that tomorrow, give this a day to soak in.
So test Thursday, Friday.
Maybe test Thursday, Friday. So, now listen. No one who's been to the board's coming to the board. I need some brave souls. D, E, and F. Or should I just?
It's so mean. How's everyone do
It's hard to find volunteers for public humiliation. Though, when you guys Santa Claus, I'm gonna be Santa Claus, public humiliation.
What does he like?
Go ahead, I'm not gonna tell you, go to the board, seriously. Well, no, it's filled up, they already got the E and F on the board.
That's what's up.
I had a student, some of you guys may remember this horror. I had one of my students, she was a superb student, wonderful student. She asked me to be in a play. And she's like, you only have one line, it's real easy, all right. I had to show up in spandex and a tutu in a play. That's horror show right there. That was horrific. Public humiliation. For that student, I was publicly humiliated. I stole the show too. You can't bottle up this much charisma. I stole the show. People had nightmares for months. So you remember that. You were scarred as a young child even. You knew it was wrong. How old would you have been? How long has that been?
I don't know.
Wait, what show was it?
It was just a comedy thing. All I remember, I had Tyler McQueen was on the stage with Dennis Morgan, and the first time ever he's been speechless. He was totally speechless. And then I added a bunch of lines that weren't supposed to be in there. What do you put yourself You understand what I'm saying?
Yeah, it's
We're like busy right now.
Watch
We're not years old.
No. Bring your height up here. Now you've got me.
Shut up.
two more.
Put two. No, you don't have a sign here. Just put two dots, two electrons.
Oh, two.
Okay, now count. 2, 4, 6, 8, 10, 12, 15, 16, 18, 20, 22, 23, 26. Now do a double bond.
Oh, I put down three.
You?
That's fine.
Oh, it's two.
Yeah, that's what I messed up. I have in there.
No, you didn't. You had two oxygens.
I thought
All right, walk away.
Wait, Mr. Weber, or sir, okay, this. What am I doing wrong?
How many you have?
23.
Because you're not putting, you need to put 8 electrons around everything to make them happy.
It's just like, she wants me to.
Now you have how many?
I
46, so make it right. It has to be from the nitrogen and one of the oxygen.
The girl that
Two,
won the
and
thing
two,
on
and double bond.
ran
Boom,
a-
okay. Very good. Everyone see that? Sometimes it's hard when you're not watching what goes on. So watch this. Technically, question. Phosphorus has how many places to bond? You notice we skipped a step here, and it's okay, they all skip it? They all skipped it. We skip, and I do this sometimes. So, step number 2, this is steps 1 and 3 right here, getting the total number of electrons. There's step 2. 6 and 5 in their outer shell. How many places can phosphorus bond? 3 places. Technically, we have, that's not right, I'm not gonna punish that. But technically, that's not right. It's harder to make this one symmetrical. You shouldn't have one there, you need another oxygen out here. It's easier to make it less symmetrical. That works. Watch this. Here's how that looks. You end up with 26. That and bonds in 3 places, so it's good, that looks good. That's not working. You have 26, you need 24, you erase 2 there, double bond. Didn't have to be down to oxygen. Watch this. You can put this oxygen. Erase 2 here, double bond. But that, watch this. Now I have around this nitrogen 2, 4, 6, 8 still. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everything's happy. You have the total number of electrons equaling the total you're supposed to be. I can't mark it wrong. We have C2H3O2. It's called acetate. It's going to be one of our polyatomic ions that we have to know. Oh, by the way, all these are. That's nitrate. That's phosphate. Later, you'll know the names of these. Okay? Now watch this. We get this. Organic chemists call it CH3CO2. In inorganic, we call it C2H3O2. They do it to kind of help themselves out. So watch this. Let me show you what he was doing here. You had, what do you have? You had it.
At first I threw another oxygen on there because I misread the thing.
Yeah, but you had your hydrogen here, right?
Yeah.
And he was stuck. So let me do this. O, O, H. No, you weren't stuck. You went okay. No, you wouldn't have been. So he's sitting there like that. And then he adds unshared pairs of electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and he's got to get down to 24. Okay? Notice see what he did there? He was at 23, and he added 1 because of the -1 charge. Watch this. This here, the way he is, where do you put a double bond? You can't do it. You can't do it the way that's written that way. Everyone see this? If I erase 2, how do I erase 2 from here? There's no, all right, if I erase 2 from here, how do I make a double bond here? There would be 10 around this carbon now. Can't be done. So watch this. If, see how it's CH3? If I move this H over to here, and put 2 electrons there, now it works. I can erase 2 from here, 2 from here, double bond. There's still 2, 4, 6, 8, 2, 4, 6, 8. I've reduced it, and that's what he did. There's still some more homework to do. The answers are on the book, and if you are, does anyone know anything about computers? Like, could you stop that? Or, oh, she's here.
Oh,